in this question, we are required to show that this derivative is equal to the expression that's given. So what I'm going to do is first of all start by finding the derivative of the given function. So if y is equal to ln of what's given, then dy over dx will be equal to, notice here that we have a function inside this given function, which implies that we are going to apply chain rule. So that will be the derivative of what's inside, which is a third into 1 plus e to the power negative 2x multiplied by the derivative of the outside. Now you know that the derivative of ln something is just 1 over that. So this will be 1 over a third into 1 plus e to the power negative 2x. So moving on, basically to find the derivative of this portion here, by the way, this part here can be written in a simpler way so that we can easily deal with that derivative. So if you expand the inside part by multiplying by a third, this will be written as a third plus a third e to the power negative 2x. That way we can just differentiate term by term. So the derivative of a third is just 0. Derivative of this, now here we have a function inside the other function, so we have this guy inside that. So we apply chain rule again. So that will be basically be negative 2 multiplied by, of course, a third of e to the power u will just be a third e to the power negative 2x. Perfect. And then here, of course, we have multiplied by this 3 can be brought up top, so 3 over 1 plus e to the power negative 2x. The 3's cancel, so this derivative can be written as negative 2 e to the power 2x over, oh, that's negative 2x, negative 2x over 1 plus e to the power negative 2x. So this is our derivative here. But now what we want to do is to proceed and show that this derivative can be written in terms of y. So from the original function, so from y is equal to ln of a third into 1 plus e to the power negative 2x. This is basically the original function. Let's convert from log form to exponential form. So convert from log to exponential form. So ln is same as log to base e. Yeah, so this is same as log to base e of that. So this can be written as e to the power y. Yeah, this can be written as e to the power y will be equal to a third into 1 plus e to the power negative 2x. And therefore, that means that this can be written, if we multiply 3 by this, so 3 e to the power y will be equal to 1 plus e to the power negative 2x, which implies that e to the power negative 2x can be written as 3 to power 3e to power y minus 1. Again, that's an important relation that you're going to apply here. Okay, so moving on, we Now want to substitute both of these equations, uh, expressions, into the original function. So substitute into dy over dx. So we'll have dy over dx, which is here, being equal to -2 multiplied by this, because now this is what we are substituting, that and that, and in place of that we want to plug in that. Okay, so what we shall end up with is -2 multiplied by 3 e to power y minus 1 over 1 plus this result, 3 e to power y minus 1. Of course, the ones cancel, so here we have dy over dx will be equal to um, -2. And by the way, we can bring this up top, so we can write this as -2 over 3 e to power -y multiplied by 3 e to power y minus 1. And this is the point where you can FOIL, so multiply out the bracket by e to power -y and -1. So you'll end up with, because you want to end up with that, so 2 over 3 into e to power -y multiplied by e to power I, they cancel out, so you end up with e to power 0, which is just 1, and negative multiplied by +3, that will be -3, plus, and of course, negative and negative positive, e to power -y multiplied by 1 will be e to power -y. So we end up with dy over dx will be equal to 2 over 3 into -3, or we can write it the other way around. This is the same as e to power -y minus 3 as required. Okay, moving on to number 13. So in number 13, we have two functions, f and g, and their derivatives, f dash and g dash. The following table shows the values for the two functions and their derivatives at 1, 2, and 3. So given that p of x is equal to the product of f and g, and h of x is a composition of g and f, find this. So for part A, let's work out part A here. So for part A, what you're interested here is the derivative of p. So p dash x will be equal to, now one thing you have to notice here is that p is a product of two functions. So p is given by f of x multiplied g of x. Now if you want to find the derivative of p, that implies that we have to apply product rule. So, and product rule states that the derivative of p will be equal to f of x multiplied by the product of g, sorry, the product multiplied by the derivative of g plus g of x multiplied by the derivative of f. So that's how product rule works. Yeah. So if you want to find the derivative of this function at a specific point, so let's say at 3 as it's required in this question, that means we are going to plug 3 in place of x. So we'll have f of 3 multiplied by g dash 3 plus g of 3 multiplied by f dash 3. Now, From the table, we can see that f of 3 is 1. So this will be 1 multiplied by. Now the derivative of g at 3 is 3 here. Yeah. So that will be 3 plus the value of g at 3 is 4 multiplied by the derivative of f at 3 is 2. So this will be equal to 3. Um, I can just write here. This will be equal to 3 plus 8, which will be equal to 11. And that's basically how you work out that part. So for part B, um, they want us to find uh, the value, the derivative of h at 2. So let's start by finding derivative of h. So now h is a composition of um, g and f. So basically h of x is equal to the composition of g and f, and it's written that way. Now here notice that you have a function inside another function. So if you want to find the derivative of h, then we have to apply chain rule. And chain rule states that you can start by differentiating outside followed by inside. So that will be g dash um, f of x multiplied by f dash x. All right, so but what we are interested here is the derivative of this function at a specific point at x is equals to 2. So let's plug 2 in place of x. So that will be g dash f of 2 multiplied by f dash 2. And then we just use our table to find specific values for this. So this will be g dash. Now the result of f of 2, so f of 2 is 1, so that's 1 multiplied by the derivative of f at 2 is 4, so that will be 4. Now notice here that now we can be able to find the derivative of g at 1. The derivative of g at 1 is just 4. So that will be 4 multiplied by 4, which will be equal to 16. And that's basically how you work out that question.